Okay, so let me just zoom to the beginning. So quadratic sequences. Thank you for joining this session. It will be 20 minutes, and I'm just going to quickly run through how to work out the nth term for quadratic sequences. So as you can probably see, well, I hope you can see on the screen, is the general nth term for a quadratic sequence. So all of the nth terms will look as follows. The only difference is that A, B, and C will be different numbers each time. And we're going to look at how to work out the A, the B, and the C. Now, I'm going to quickly run through with you the proof of this. Now, you do not need to remember this at all. Okay, I'm just going to show you so you understand where it comes from. But if it just kind of flies over your head, then don't worry about it, because at the end of this, I'm going to show you 3 simple equations that you need to remember to help you find the nth term of quadratic sequences. Now, before we start, you probably would have learned it differently at school, okay, which is absolutely fine. You can pick and choose which method you prefer, okay, and I'll tell you the specific thing you need to remember to get the first mark in these generally 3 to 4 mark questions. Okay, so if you have any questions at all through this session, then please just write in the chat and I'll get to them when I can, or as we go along, or even at the end if I don't get a chance, okay? So, right, quadratic sequence. If you've done quadratics at all in school, then you'd know that it would look something like x squared plus something x plus a number. Okay, and we know the number in front of the x squared we call a, the number in front of the x we call b, and the number at the end we call a c. So notice this is exactly the same as the nth term for quadratic sequences, but instead of x, we have n. The n represents the term in the sequence. Okay, so n represents the term in the sequence. So if you wanted, for instance, the 100th term in the sequence, you would substitute n is equal to 100. Okay, so looking at this nth term that we have here, I'm going to list out what this sequence could be. So for instance, when n is equal to 1, the first term in the sequence would be a times 1 squared, which is just a, and then b times 1, which is just b, and then c. So that's your first term. The second term, when n is equal to 2, you would have a times 2 squared plus b times 2 plus c, which gives me 4a plus 2b plus c. And the third term would give me a times 3 squared plus b times 3 plus c. So all I've done is substitute in the term I want into our n. So that would be 9a plus 3b plus c. Just to repeat, you do not need to remember how to do this. Okay, I'm just showing you where it comes from, and we'll get to the easy part in a second. So now, this is the general quadratic sequence, okay, which works for any numbers. So with quadratic sequences, you want to know what the difference is. So if I looked at this, and I said, what is the difference between 4a plus 2b and c and a plus b plus c? When we say difference, we just mean subtract. So 4a take away a is 3a, and 2b take away b is b, and then c take away c is just 0. So that's fine. Then the difference between these two, so you do 9a plus 3b plus c, take away 4a plus 2b plus c. So you get 5a, and then 3 take away 2b is just b, and then c take away c is 0. Okay, so this is what we call our first difference. And the second difference should be the same. And it's just 5a plus b take away 3a plus b, which gives you 2a. So this is 2a. If you're confused, just bear with me, because it's going to get a lot simpler in a second. So what I want you to look at here, I'll just remove these as well, is the first term in our sequence, we will label as a plus b plus c. Okay, so that's really important here. The first difference you label as 3a plus b, and the second difference as 2a. Okay, I've shown you where these equations come from. You do not need to remember how to do this, but these three equations that I've highlighted is what you need to remember. So how do we use these? I'm going to show you in this example here. So this is a sequence, -2, -1, 2, and 7, and we want to work out the nth term. So what you always do is in any kind of sequence, you look at what the difference in the numbers are. So from -2, to get to -1, you're adding on 1. From -1 to get to 2, you're adding on 3. So it's different here. So notice it's not a linear sequence. The first difference is they're all different numbers, and then 2 to get to 7 is 5. So we say that our first difference is 1, 3, and 5. And now let's work out our second difference, which is, so the difference between 1 and 3 is 2. The difference between 3 and 5 is 2. Notice it's the same number now. Okay, going back to our equations, how are we going to use them now? So what you say is, this is our a plus b plus c. So we say a plus b plus c is this. This term here is your 3a plus b. Let me just remove that so it doesn't. This is your 3a plus b is equal to 1. And then this plus 2 is equal to the 2a. So the first thing you do is we work out 2a is equal to 2. So if 2a is equal to 2, divide both sides by 2 to get a is equal to 1. This is the number that goes in front of the n squared. Get rid of that. So it's 1. Now you need to write this to get your first mark. So all you need to do is work out all your differences and then divide this number by 2 and write it in front of the n squared. That will give you 1 mark. So we've got our a, and then the second equation is 3a plus b equals this here, 1. So we know our a is 1, so 3 times 1 plus b equals 1. So 3 plus b equals 1. Subtract your 3 from both sides. If you took part in my solving equations lesson last week, you should be okay with solving these pretty quickly. If not, make sure you go back and watch that if you get stuck or if you don't know what I'm doing here. So 1 take away 3 is -2. I've specifically used a lot of negatives here to practice your negative numbers as well. So this is, the b is your number that goes in front of the n, and now we're just left to work out what our c is. So you say a plus b plus c equals -2. We put in our a, which is 1, we put in our b, which is -2. So 1 take away 2 is -1, and you add 1 to both sides to get c is -1. So our last number at the end is -1, and this is your nth term. So all you need to do is remember these 3 equations, b and a plus b plus c. Okay, so first thing you do, work out what is the difference between 1 and 4. It's 3, then 7, and then 11. So that's my first difference. My second difference is 4 and 4. So the first thing I write is 2a equals 4. So my a must be equal to 2. And I'm going to write 2n squared. You need to write this to get the first mark, okay? So you need to write the number in the 2n squared. So if you don't remember anything else, make sure you get this to get your 1 mark. Okay, so we've done our 2a. Then the next equation is 3a plus b equals 3. So I'm going to do 3 times 2 plus b equals 3. So 6 plus b equals 3. Take away 6 from both sides to get b is equal to minus 3. So I write minus 3n. And your last equation is a plus b plus c equals 1. So our a is 2, our b is minus 3. You put your plus c is equal to 1. So you get 2 take away 3, which is minus 1, plus c is equal to 1. Add 1 to both sides. The c must be equal to 2. And that is your last number. And if you can have a go at the one on your right, and I'm going to give you about a minute to do so. We work out our difference. So we're plussing 5, plussing 7. If I make a silly mistake here, let me know. 15 plus 9. Okay, and then we'll check again. So the second difference is 2. If the second difference is not the same, then you've done something wrong, or it's not a quadratic sequence. Okay, so we work out what our 2a is. So a must be equal to 1. And make sure you put that in front of the n squared, or just n squared is fine. And then the next equation would be 3a plus b is equal to 5. So you do 3 times 1 plus b is equal to 5. 3 plus b is equal to 5. B is equal to 2. You subtract 3 from both sides. So, okay, and now the last equation, which I'll write here, is a plus b plus c is equal to 3. So we know our a is 1, our b is 2, and we need to work out what our c is. So 1 plus 2 is 3. So c must be 0. So you put plus 0, and we don't need to write that. So our nth term is this. The difference between 9 and 19 is 10. 19 and 33 is 14. Okay, so 14. 33 and 51 is 18. So then the difference here is 4. Again, I'm checking my second difference is the same. So 2a is equal to 4. So 2a is equal to 4 divided by 2. My a is equal to 2. So you write that in front of your n squared. Then 3a plus b is equal to 10. 3 times 2 plus b is equal to 10. So 6 plus b is equal to 10. B is equal to 4. So plus 4n. And then a plus b plus c is equal to 9. So a is 2. B is 4. And then we want our c. So 6 plus c is equal to 9. C is equal to 3. So you put that at the end. Right, have a go at the last one on the right. 2n squared minus 3n plus 2. Right, okay, so last thing, before I'm going to give you an exam question. Before I give you the exam question, you can use these nth terms to work out any term in the sequence. So for instance, what is the 100th term? That means you're going to substitute in n is equal to 100 into this. So you're going to do 2 times 100 squared minus 3 times 100 plus 2. So always put the number you're substituting in brackets. So always get into the habit, substitution, put the numbers in brackets. That minus 300 plus 2 is equal to 19702. Okay, so this one, so 19,702 would be the 100th term in that sequence. Okay, so before we go, because we have reached the end of the lesson, but I want you to have a look at this 4-mark question. So the nth term of the sequence is given by an, and that should be a squared there, an squared plus bn. The second term of the sequence is 4. The fourth term of the sequence is 32. So if you're watching the replay of this, just pause the video at home and have a go yourself. So what it says here is the second term of the sequence is 4. That means that n is equal to 2. And you're going to substitute that into the an squared plus bn. So I'm going to do a times 2 squared plus b times 2, which is 4a plus 2b. And we're told that it's equal to 4. So we have an equation here in terms of a and b. The next part says the fourth term, so when n is equal to 4, 4, which gives you 16a plus 4b is equal to 32. Now notice we have two equations that are in terms of a and b, and we know that a and b have to be the same value. So these are what we call simultaneous equations, and you can solve it just like you've been solving all your other simultaneous equations. There's a reason why this question is 4 marks, okay? Have a lovely evening. Thank you so much for joining this session. If you have any questions, please feel free to write them in the chat now, and I'll stay on for another few minutes. Otherwise, thank you so much, and I'll hope to see you in another live lesson.